Hello everybody. So we are still talking about the energy balance for open and closed systems, and now we are talking about the terms of enthalpy and internal energy. We need to figure out how to calculate or find their values, and we agreed that we will depend on the or we'll do our calculations on the change in the internal energy and change in enthalpy, not the absolute values, because we cannot calculate the absolute values. Now there are some concepts that we need to understand before we proceed to the ways we get the data from tables, or we calculated them the values ourselves. One of the very important concepts is the concept of a state property and non-state property. A state property and non-state property is one very basic thing, and based on the definition of a state property, we will be building our strategy for calculating the change in enthalpy and change of internal energy. So it's a very important thing to be known. So to understand the difference between a state property and non-state property, let's take an example of pure water at 40 degrees Celsius and 1 atmosphere. Just water, nothing else, at 40 degrees Celsius and 1 atmosphere. And I have two samples. One of them originally was ice. This ice melted, producing liquid water, and it was heated so that its temperature reaches 40 degrees Celsius. The second sample was originally water vapor that was condensed and cooled until its temperature became 40 degrees Celsius. So the final result in the two cases is the same. It's water at 40 degrees Celsius at 1 atmosphere, liquid phase, pure water. The difference is the previous state. So let's say I want to calculate or measure the density of the two samples. Will it matter if it was originally ice or vapor or not? This is the question we are trying to answer. So for the density, the information that we need to know are the current information of the water, the temperature, the phase, the pressure. This is and the composition if there is a mixture of more than one compound. So these are the information that I want to I must have in order to find the density. So according to this, the density is called a state property. State property means that it's a property that depends only on the current state of the system. It doesn't depend on the previous history. So the density of the water that was originally ice is the same as density of water at the same conditions that was originally water vapor. So the previous state doesn't have any contribution to the current value of the property that we are interested in. So this is what we call a state property. So the state property is a property that does not depend on the previous state of the material. It is not dependent on the previous state of the material. It depends only on the current state, and by this we mean the temperature, the pressure, the phase, and the composition. So there are many state properties. There are a lot of them. So the state properties, examples of the state properties are are the mass. If you have something that you want to measure its mass, you don't care if it was a small mass and then another mass was added to it, or it was big and you took some of it. At the end of the day, the mass is the mass. You just see what you have and you measure the mass. Composition is the same. If it was very diluted and you concentrated it, if it was concentrated and you diluted it, it doesn't matter. The viscosity, the density, the specific internal energy, and specific enthalpy are state properties. And this is the point that we want to refer to here. The specific internal energy and the specific enthalpy are state properties. This is extremely important to know. So if I have a system at specific conditions of temperature, pressure, composition, all what I need to know is the current conditions of the system. It doesn't matter how it reached these conditions. This is very important. This is what I want to the point I want to make out of this slide, is that the internal energy and enthalpy, or specific internal energy and the specific internal energy, specific enthalpy, are not dependent on the previous state. This is very, very, very important. So I hope this point is clear. Treat it as you treat the density. You don't care what was the previous state. You just care about the current state. The non-state property, you might think that everything is like this, that all the properties are state properties. There are no properties that I would be interested in their previous state. But actually there are. And to take an example, let's look at this piston. For example, for this piston, if I'm just showing you the piston at the current state, at the current temperature, pressure, and at the current level for the piston, can you tell me if this how much work this piston is making or is doing? The answer of this question is no, because there are other options. There are more than one option. There is an option here that the piston was originally low, at lower height, and the system pushed the piston upward. So this is one case, and there is another case that the piston was up and it was pushed down. So here the work is negative, and here the work is positive, and the state is the same. So here you would see that the property, which is the work, it's not a state property, it's a non-state property, because it depends on the previous state of the system. If you know the current state of the piston, you will not be able to tell how much work it's doing or is done on the system without knowing where it was before. So the previous or the original state is important to know the value of the property. It's very, very important. Without the previous conditions, there is no way we can figure this out. So this is a very important thing. Again, the point I want to make out of this video is that the specific internal energy and specific enthalpy are state properties. I do not need to know the previous state, or the previous state doesn't matter, in order to calculate the current condition or the current value of the specific internal energy and specific enthalpy of the system. So I hope this point is clear, because as I told you, this is going to be a very, very basic concept, and we will be building a lot of our strategies of solution on this principle or in this fact. So next time, inshallah, we will be trying to answer this question, which is how can we calculate or find the value of H that we use to calculate delta H. So this is a very important question. Still, there are some concepts that we need to go through in the coming few videos, and after this we will be looking at the ways of calculating H and delta H. So I'll see you next time, inshallah. Goodbye.